Hey guys, and welcome back for Chapter 18 of AP Stats. Today we're going to start looking at confidence intervals for proportions. Now, to help you kind of understand what's going on, I'm going to tell you like a brief scenario to kind of get you into the mindset of what this means. So let's say MrCaproni wants to go out and I want to find out what proportion of all seniors in high school across America have a job outside of school. All right. So that's kind of what I want to go about finding out. Now, is it possible for me to ask every senior in America if they have a job or not? No, I just don't have the time or resources to do something like that. You trying to say my high school job don't matter? Last time I checked, you weren't listed as essential. So, what am I going to do instead? Well, I'm going to ask as many people as I can and try to get a good estimate for the whole population from that. So, I reach out to, let's say, 100 random teachers, all right? And those 100 random teachers, I have them ask 30 students at random if they work or not. And then I have them submit to me the proportion of students that said, yes, I have a job. All right. Then I take all of theirs and form a sampling distribution with a proportion for my sampling distribution. All right. And I now have this strong piece of data. And what I'm going to do with the proportion of that sampling distribution, where I've collected the proportion of all of these different teachers, all right, is I'm going to use that to make a guess about the whole population. Now, is my guess going to be perfect? No, there's going to be some issues with it, but it's going to be a really, really strong guess, all right? So I'm going to use that guess, the group of samples that I got from all of these random teachers, and I'm going to use that to make a guess as of what the proportion of all seniors in America, what proportion of them have a job outside of school. So that's kind of the launching point of what this chapter is about, and that's how we're going to be using this whole confidence interval thing. Because a confidence interval is just that. It's using a sampling distribution outcome in order to make projections about a whole population. All right? So let's go ahead and dive right into the notes and check and see what's going on. As mentioned, we're looking at Chapter 18, which is called Confidence Intervals for Proportions. First thing we're going to do is remember a little bit from last chapter what we were looking at. If you remember, this was the formula for the standard deviation of a sampling distribution. So this told us on average how far away our sample proportion should be away from the true proportion. Okay. The issue here is we don't know P. All right. So in a confidence, like how we were talking about at the beginning about who has a job, who doesn't have a job, and so forth, we only knew what proportion of our sample of students had the job. We didn't know the true proportion. So if our formula from before, the standard deviation formula, uses P, that's the true proportion of the whole population. But we don't have that. So does that mean we're stuck? Does that mean we can't move forward? No, it actually doesn't. What we're going to end up doing is using that sample statistic to estimate our population parameters. So we're kind of going to be going from the flip side where we have our sample and now we're going to use that to make a guess for the population, all right? But whenever we use this estimate of the standard deviation using our proportions from our sample, we no longer really refer to it as the standard deviation of the sampling distribution. We will now start to call it the standard error. And remember, because we're no longer using the true proportion, we will not be using P anymore. We will be, well, I mean, we will when we're talking about the true proportion, but when we're talking about a lot of these stuff, we're now going to switch back to using the P hat, because remember, that means it's the proportion of our sample, okay? So we're going to move forward now calling this a standard error, not a sampling distribution standard deviation, because we are no longer using the true proportion in the formula. All right. So officially, what's that look like? Looks like this. It says for a sample proportion, the standard error is the square root of p hat times q hat divided by n. Remember, p hat is just going to be the proportion of our sample. So in this case, that would be the proportion of success. So that would be what percent of our seniors in high school have a job. Q is your proportion of failure. So in this case, it would be what percent of the students don't have a job. And then n, remember, is just your sample. So recall that the sampling distribution model of p hat is centered at p with a standard deviation of the square root of p times q over n. All right. Since we don't know p, we can't find the true standard deviation of the sampling distribution model, so we need to find a standard error. So here's what it's saying is, remember, in what we were doing in previous chapters, we had this normal curve that came out for the sampling distribution. P was in the middle of that, and then it went up or down by this guy. It's saying we now have a standard error, which is this guy, but we're not going to be able to have a perfect thing around P, but we're going to talk about what we're going to be doing instead. So by the rules of our little 68, 95, 99.7 rule, also known as the empirical rule, we knew that when we were looking at this, all right, and if P was in the middle, we knew that if we ended up getting a P hat in our sample, that 68% of all samples would have a p hat that would be within one standard deviation of this p. All right. We knew that 95% would be within these two standard deviations, and about 99.7 would be within three standard deviations. Now, we don't have p. This is what we're trying to find. So we can actually now look at it from our p hat's perspective. Let's say p hat ended up falling, I don't know, let's go with a different color. We'll say p hat ended up being right here. All right. So this was our p hat that we ended up getting. Was it within one standard deviation? It looks like we're slightly outside of one standard deviation. All right. But now we're saying, let's look at this from p hat's point of view instead of from p. Meaning, how about now I look at p hat, all right, and by the same argument as this stuff right here, we should expect p, our true proportion, to still be this distance away, all right? So in other words, before when we started at p, we knew p hat should be within this distance, two standard deviations. So if I go within two standard deviations of p hat by the same argument, P should be within that range, all right? Just because we're still talking about the same distance going back and forth between the two, all right? So when we consider the 95% level, if we reach out two in either direction, we are 95% sure that P will be in the interval that we create. All right. In other words, if we reach out two standard deviations in either directions of P hat, which is that little picture that I just drew, we go two standard deviations in either direction, we can be 95% confident that the interval being from this number right here to this number right here, that's our interval, all right? We can be 95% confident that the true proportion P will be somewhere in that range. Now, we don't know if it'll be down here, right here, right here, right here. We just know it'll be somewhere in there. This is called a 95% confidence interval. This is very important. This is what the whole chapter is about. We call it a 95% confidence interval when we are 95% confident that the true proportion is going to be somewhere within the interval we create. Okay. So this is kind of a little picture that's going to help demonstrate that again. We go out, we find p hat, all right, and then we say, all right, now that we know p hat, by the same argument before, we know that the true proportion should be within two standard deviations of that 95% of the time. So because p hat should be within two standard deviations of p, then p should also be within two standard deviations of p hat. It's just using the same distance going both ways. So again, it says reaching out two standard deviations on either side of the p hat makes us 95% confident we'll drop the true proportion p. Now, again, why do we keep using 95? Because 95 has been that standard two standard deviations away. By that rule, 95% of the population falls within that range. So that's why we're still sticking with kind of the same percent, the same idea of two to work through this material. All right. Let's go ahead and see what this would actually look like for us in this problem. What proportion of seniors have a job? That was the question we were asking. Let's say I went out and did get a collection of 300 students for this question. And I found out that the proportion of my sample was 30%. 30% of my 300 students ended up having a job, okay? So if I wanted to try to find out, use this to find out what proportion of all seniors across America would have this? Well, first off, we would have to make sure that my sample kind of met a bunch of conditions, but we're going to talk about that in the next video. But for right now, let's just assume this was a good sample, it was solid. How would I use it to figure out the actual proportion? So this is using the formulas we have talked about so far today. So I already have in here that p hat was 0.3 because that's our 30%. I have n as 300 because I just told you guys it's my collection of 300 students, okay? So I would plug this all into our formula. Now remember, the goal here is that we're going to end up having kind of this normal curve with our p hat somewhere in the middle there, all right? And we're going to use this standard error to go out 2 standard deviations in either direction. And we're going to claim that somewhere in this range, all right, should be our true proportion. The true proportion should be somewhere in that range. So let's go ahead and take a look of what plugging this in would look like. All right. Because my handwriting gets so sloppy on here, I went ahead and tried to already put some of this information in here. So first off, p hat. What would p hat be? P hat would be our 30%, so 0.30. What would Q hat be? Well, remember, Q hat is just always the opposite of that. So if you had 30% out of 100%, take away that 30%, and that leaves you with 70% of the students would not have a job. So 70% would be our Q hat. So we refer to that as 0.70 or just 0.7. And I already have N labeled up here as our 300. So let's go ahead and plug that all in. And you can see there I got square root of 0.3 times the 0.7 over the 300. When you plug that in your calculator, you should end up getting 0.026458. In other words, about a 2.5, 2.6% standard error. So our standard error means basically that when we start here at our p hat of 0.30, we are essentially going to add and subtract this number twice to get 2 standard deviations away. And then we're going to subtract that number twice to get 2 standard deviations in that direction so that we have an interval to look at here, okay? So let's go ahead and do that work. Let's just go ahead and we're going to take this number, we're going to add it to 0.3 twice, and we're going to subtract it from 0.3 twice to get our 2 numbers in our interval. What is that going to look like? Here you can see I went ahead and took my 0.3. I added that number, just moved that number over, times 2 because there's 2 of them, and I subtracted that number times 2. All right. The 2 answers that it should give us here are 35.29% and 24.70%, or 71 if you're rounding. All right. So what does this mean? It means that if I go back to looking at this picture over here, all right, it means I have created an interval now that is from 24.71% to 35.29%. Now, that is important because what's that telling us? That is telling us that with 95% confidence, I believe that out of all seniors in America, I expect somewhere between 24 to 35% of them to have a job while they are a senior in high school. Okay, so I would expect somewhere between 24 to 35% of them to have a job. And I can say that with 95% confidence, which is extremely confident. If I could guarantee I'd be 95% correct on everything in my life, it would be a fantastic thing. Cool? One of the things that gets really confusing in this chapter is what a 95% confidence interval really means. All right. So when you say that you're 95% confident about something, does that just mean it happens 95% of the time? Does it mean that your answer is correct 95% of the time? Is your true proportion inside your thing 95% of the time? It gets a little confusing. So it says here that each confidence interval uses a sample statistic to estimate the population parameter, but since samples vary, the statistics we use and thus the confidence intervals we construct vary as well. What is this saying? It's saying that, okay, we've now created an interval, all right? We've created an interval. And that interval, we believe, will have the p, the true proportion, somewhere inside our confidence interval. All right, it should be somewhere in there. Will it always be in there? No. Maybe we had a sample that was really, really high and p actually ended up falling out here. Or what if we had a sample that was really, really low and p actually ended up falling up here? All right. So we can't guarantee our sample is going to be perfect. But if we follow this process of creating a 95% confidence interval, we would believe that it's in there 95% of the time. So let's look at what that means here. It means you can see here, this is a crazy looking graph. It's got a lot going on. All right. But it's saying, hey, if I knew the true proportion, let's assume that the true proportion of kids, like let's say I actually asked every kid in America if they had a job or not. And the answer ended up being that 32% of them did have a job. And I went out and took 20 different samples of high school students using our methods of finding a confidence interval. Okay. So I did it 20 times. That whole process that we just did back on this slide, I do this whole thing 20 times. I go out, I take 300 kids, and we go ahead and create our confidence interval. What this graph is showing you is what that could look like. If 32 was our true proportion, and we didn't know it at the time, but now for whatever reason we do, 32 is the true proportion, then this green line would represent that true proportion, okay? These represent all of our confidence intervals, and the red dots would represent all the p hats that we got for each sample, all right? So if you look at all the p hats, are they always exactly 32? No, they're not. All right. Sometimes they're above, sometimes they're below. But you can see that most of the time, the confidence interval, which is the little blue like lines here, the confidence interval, the green line's almost always within the confidence interval. Okay. Now you can see at this one right here and this guy right here, and I think there's another one right here. All right. Those three were actually the p hat was so far away that the confidence interval did not like fall in a way that the green line would be on top of it. Now, we don't want to say that 95% of the time P, the true proportion, will be within our confidence interval because that makes it sound like the P, the true proportion, is changing. But in the world right now, there is a set percent of seniors that are working and a set percent that are not. That number's not changing. That's our P. That number is set. It is ready to go. Instead, what's changing? Our confidence intervals are changing. Every time we grab a sample, we are getting new data, new information with a new p hat, with a new standard error, and everything is new and fresh. So instead of saying that 95% of the time the 0.32 or the true proportion will fall within our confidence interval, instead we say that 95% of the time our process of creating a confidence interval will create an interval that has the true mean inside of it. So it's not the fact that the true proportion's changing, it's the fact that the confidence interval is changing. So 95% of our confidence intervals will have the true proportion inside of it. All right. And that's kind of what this last slide is going to bring together. It says that our confidence is in the process of constructing the interval, not in any one interval itself. Thus, we expect 95% of all 95% confidence intervals to contain the true parameter that they are estimating. So this is kind of just semantics. It's just, stick in the mud, but it's the type of wording that on an AP test, they would expect you to understand the difference. It is not that the proportion is inside of our range 95% of the time. It is that when we create a confidence interval, 95% of the confidence intervals we create will have that set P within our range. Hopefully, this was a good intro to you guys to start understanding what a confidence interval means, what it is, and how we'll go about finding it. Over the next few videos, we do have a few things we will be looking on to kind of move forward with this, such as what are the assumptions and conditions we'll use for this. We did it for a rough estimate of 95%, which was 2 standard errors away, But what if I wanted to only be 90% confident? Or what if I wanted to be 100% confident, if that's even possible? What if I wanted to be 99% confident? We're going to talk about how you go about creating confidence intervals like that. Then later on in some future videos, we're going to look at things like how do you choose a sample size to get the confidence interval you want? Is there a wrong way to go about doing this? So this is going to be what chapter 18 is looking at. I don't want you guys to freak out because it looks like we have a lot of chapters ahead of us, but these next few chapters are kind of going to hit like rapid fire, one after the other, all right? Chapter 18 is going to focus on confidence intervals for our proportions, but then we're going to move forward to hypothesis testing in chapter 19. Then 20 will just be a bit more information about hypothesis testing. Chapter 21 is still going to be dealing with confidence intervals and hypothesis testing for proportions, but it's going to deal with two different proportions instead. After chapter 21, it's going to be the exact same thing again. The only difference is we're going to be looking at it as quantitative data instead of looking at proportions. So just like how we did with sampling distributions, we're going to have, instead of proportions, we're going to have a mean and standard deviation, and we're going to do the confidence intervals, the hypothesis testing, and the two of them at the same time stuff again. So that means that we have the potential to crush through like 8 or 9 chapters in a matter of 2 weeks. That may seem daunting, but I promise you, once you get this chapter down, the next chapter, the material kind of just repeats over and over again until the end of the year. So we are almost there, guys. So stick with me, keep working. We probably have another like 3 solid weeks of work before we can start reviewing for the AP test. Now, I am going to try something a little new. I'm going to upload all of these videos to YouTube, so it's all there on the same place. If you ever want to go back and check anything out, you can find it on there. What you can do is you can search MrCaproni, and you can either find the videos on YouTube, or you can try to reach out or see what kind of things that I've been talking about outside of class at MrCaproni on Twitter. So in either case, YouTube or Twitter, go ahead, search for MrCaproni, and you should be able to find the content. Well, as always, guys, I hope you were able to get something useful out of this video. Stay fit, stay healthy, and have a great week.